Welcome to The Dot is Black. I'm David, and this is the first video of 3 where I would like to talk about how to export images. And I will talk about image types, image sizes, also how to export images with a timestamp for file names. In the second video, I would like to talk about transparent images or images with transparent backgrounds, and also how to export the images as large images to be printed for high quality prints. And then of course in the last one I will talk about vector images, how to export them into PDFs or SVGs. The fourth video after this is finished will be how to export videos and synchronize the code with music, something that you usually see in my art tutorials where usually the introduction is always perfectly synchronized with the audio. Alright, let's get started. Here you can see Photoshop. Photoshop or Illustrator, those are very popular softwares if you don't know them. Photoshop is good for raster images, whereas Illustrator is for vector images. What I want to show you here is when we, for example, want to save the file, this file that I have open right now, you can see a lot of different file types. Yeah, and the most important ones, or at least the most common ones that you know, is perhaps bitmap. Then we have JPEG, we have PNG, and also a TIFF file. Same in Illustrator. When we open Illustrator, I also try to save here the file. Illustrator is for vector graphics. When we want to save here this particular object, or the dot is black here in this case, the graphic, we can see we have less options for saving it. The most common are AI, PDF of course, EPS, and then SVG that we know also. And I also will talk about PDF and SVG particularly here. Alright, so what is the difference between raster and vector? Well, simply raster is based on solid square pixels where each pixel is recorded and each pixel is assigned a color and also a location within the image. Therefore, certain images, when you have a lot of colors, they become quite large. The problem with raster images is, as you can see here on this image, the edges become quite blurred, or they're not very crisp and sharp when you zoom in, or when the pixels are low, like in this case, for example, maybe like 40 by 40 pixels, I guess, or something like this, or 30 by 30 pixels. And on the other hand, we have the vector graphic, and vector graphics are not based on pixels, they're actually based on points, lines, and curves with coordinates. And you can zoom in and zoom out without losing any quality, because vector images are not based on PPI, or at least on pixels per inch in this case. So the most common types for raster images are TIFF, JPEG, PNG. And one thing to remember is, I will repeat this later again, processing saves images at 72 PPI. And PPI means pixel per inch. This is usually applied for digital displays, whereas we use DPI for printers, which means dots per inch. So for high quality prints, you need at least 300 PPI of your image. So if you see already there is a problem, if you save raster images with processing and they're only 72 PPI, the quality will be quite low in terms of printing. And the vector images, the most common types are PDFs, SVGs, AIs, and EPS. And vector images have the quality that you can scale without losing any image quality. And they're not based on PPI. So let's have a look at those 4 images. Let's compare them. Those are usually the types that I myself mainly use. I don't use much TIFF files in this case. I usually use JPEG, PNG, PDF, and SVG for particular purposes. And on the first side, you can see that all those 4 images, they look all the same, but they are actually quite different. So let's have a look in detail. JPEG or GPG or JPEG means Joint Photographic Experts Group, or Joint Photographic Group in this case. And most of us work with JPEG files, mainly when you would take photographs, for example, because the file sizes are small and the images are compressed. Yeah? So when you compress, they lose quality. But in processing, it's very easy to use those JPEG files because We can also usually extract colors from it or shapes, but like I said, it loses quality. We can see this here when I zoom in this particular left side. You can see already the image is very blurred and the colors are not evenly distributed. There is a lot of noise because of the compression. The next one is PNG, Portable Networks Graphic. And PNG files were developed, I think, 1995, as I remember, and they were there to replace GIF files. GIF files were always limited to 256 colors, whereas PNG files, they don't have any limitations. And they're actually quite powerful. They're really, really good because they have no loss in quality. They have maybe larger file sizes, but they have no loss in quality. And additionally, you can save PNG files with transparency or transparent backgrounds. And that's quite useful, particularly when you want to work with maybe logos, for example. You want to export logos from processing. But the biggest advantage is that the compression of the PNG file is lossless. So when we look inside this image, you remember the JPEG file had already a lot of noise here within the black. It was not even, whereas the PNG file is much more even. And also the edges are much sharper. So that's actually quite a very good image type. And the other aspect or the other advantage of PNGs is that it handles detailed and high contrast images very well. So most of my works that I export are usually PNG images or my raster images. And you can see also here, of course, the transparency. So you can always overlap and it's quite beautiful. You can use those PNG files as well in your processing sketches. Now the next one is PDFs or PDF, portable document file. And this is what we mostly use in everyday life, whether you work in an office or whether you share files, because it's kind of easy. It's very easy to open them. Everyone has a reader, PDF reader, and the quality is always very, very high. So the advantages of PDFs is sharing small file sizes. However, also, of course, the files can be very, very large if you have too many objects inside. So when you want to save in processing certain PDFs, where you have maybe like 10,000 or 100,000 of objects, perhaps maybe like circles, the files become incredibly big. The advantage of PDFs is, of course, you can scale, and you always retain the high quality. And it's also the best option for high quality prints if you work with graphics, simple graphics. And additionally, of course, you can use it for pen plotters, or you can always export it. You can even use PDFs and translate them into DWGs or DXF files, for example, for CD softwares, where I can open up in AutoCAD or in any 3D software. So there is a lot of intersections using PDFs. The next file is, or the next type is SVG. It's called Scalable Vector Graphic. It's also a very good image type to know, because the files are also very small usually, and we can apply this file type in various cases, for example in web design or also in processing. You can see P-shape, and I also will later do an example on that. And as well, SVG files are kind of better than PDFs for pen plotting. And that's how the SVG files look like. They are different than PDFs. So if you open an SVG file in an editor, like in this case Notepad, you can see the file is not anymore pixels, but actually it has coordinates. And this particular case, you can use it in an HTML code in a web design, and you can open it up without using an raster image. The nice thing about that is you can scale in, scale out, and you can even apply JavaScripts to manipulate this SVG file. So I'd like to show you this example. I will talk about this in a future video, particularly how to make this graphic with an SVG file. And it's quite a simple code, because when I run it, so you can see I even can animate SVG files, so vector files, that I can draw in Illustrator. And then I simply just load them into the processing sketch, and I can manipulate it. To make this graphic in processing, it involves a lot of work, particularly in terms of curves, maybe also different anchor points. It's quite difficult to do it. And I think also SVG files are a bit underutilized in creative coding, because they offer a lot of possibilities. All right, let's go to image sizes. you know, like for example, for example, typical types like A0, A1, A2, A3, A4, A5, and then the rest is too small perhaps. But those are the very typical sizes to print things out, whether it's a plotter or maybe A3 printer, A4 printer. And I want to show you this particular case because remember, processing saves images as 72 dpi or ppi. And if we want to open a new window, for example, in Photoshop, so you can see you have here a lot of options. And when we go into photographs, every image here is set up as like 4x6 inch and 300 ppi. So you can see here also 300 ppi. Print stuff, like when we say, for example, A4, we have 210 by 297 millimeter at 300 ppi. Yeah, same like art illustration, also 300 ppi. Web design is different. For web pages, graphics, we usually use 72 ppi. And then mobile devices, the same case. And also, of course, video as well, 72 ppi. So this is something necessary to know. For print images, we need always 300 ppi, yeah, pixels per inch. Whereas for mobile devices or digital screens, we always need only 72 ppi. Although there is, of course, a difference. Some screens have 96 ppi, some others have 144 or even more, like with the Retina displays. So the density of pixels is much higher. But processing exports 72 ppi always. Now, the problem is, of course, if processing exports only at 72 ppi, but we need raster images at 300 ppi for printing, so we need to also a bit calculate this case. But before you start any sketch, or if you want to export things, you have to also always think about for what is the image for? What is the output size and what is the medium? So for example, is it for digital displays? Is it for high quality prints? Or is it perhaps even for a pen plotter? Each of these different output of these different mediums have different requirements. And that's quite important because the way you structure the sketch, if, for example, maybe you write a small sketch and it looks quite nice on your screen, but once you want to maybe make a high quality print, you realize the image is too small. So you have to increase the pixel sizes in your window, but then you don't see the image. Or maybe the image doesn't really relate to it. It looks kind of everything you have to set up manually, you have to continuously change it. So it's very important to understand this difference. So when you have here, for example, if I want to, for example, export an image that is A4 size in processing, so I usually write in setup 595 pixels by 842 pixels. Yeah, this is at 72 ppi. That's what processing would output for me as an A4 image, but it's only at 72 dpi. However, if I want to print out this image with a nice high quality printer, then I would need to write in the size, I would need to write 2480 by 3508 pixels. And you already see the problem, because if I write this in the window size, 2480 pixels, or the height is 3508 pixels, the image will be not visible in your window. So that's a problem already. Now, why I show you these two things, I will talk about this even more in detail in the next two videos, especially how to export the raster images and how you can actually see the image on the screen. But for example, when I export A4 images or A3 images in processing that I want to use for my pen plotter, I usually use 72 ppi, because 1 pixel on the screen usually equals the tip of the pen that I usually use in my case. So you can see here on the left side, 1 pixel of this particular tip of the pen. If I make the sketch, the processing sketch, it always creates a very nice, beautiful, almost even solid filling. When I do 2 pixels, there is always like 1 pixel distance between the lines, and then 3 pixels and 4 pixels. And that's for me basically a nice reference if I choose different pens. So one more time, if you want to use certain images, for example, as sketches for pen plotting or PDFs in this case, I will use the pixel sizes with 72 ppi. Whereas when I want to make print images, with 300 ppi, I need to increase the pixel size of the sketch. Yeah, so those are two different things. Those are only for raster images, not for vector images. Yeah, so those are two different things. And of course, the higher you go, for example, a 0 scale or even much higher, so the image, the pixel size becomes incredibly large, and of course, the computer needs to work more. Therefore, actually always, yes, vector images are always better because the file sizes are smaller and the computer can run faster, and you can actually also see better what's on the screen, what you're doing there. Okay, so let's start a little bit and talk about how to export raster images with a timestamp in processing. Okay, so here we have this basic sketch, and you know this already from, I think, episode 27. It's the generative circle, where the inner circle is always changing based on random values. Yeah, like here x is random 250 to 300 pixels, and then we just fit it into the line as an x, and that's always changing it. Now we want to save this image, so let's start, and we say if I press the key, so for example, if I press key S, I want to save the image. Yeah, so we could also, of course, include this if function into the draw, but it's not necessary because it's always continuously will run, and I usually like to keep this as a separate tab or always copy paste into the code again. Yeah, so all right, so we have this key S, and now we say save image. Yeah, so here we call it maybe the first image, and I give it JPEG ending file type. All right, that's basically it. Let's start the sketch. Here we have, and now I'm pressing S, and the image is saved. I hope. I don't see anything actually. So what to do? We need to give it some feedback. So what can we do is, so we say print line, and then we say basically saved. Okay, and there you go. It says saved. Now I save the image. Let's check it out. How does it look like? There it is. This is our first image, and it's just 351 pixels. If I zoom in, so that's it. Yeah, because I had the size of 842 pixels only. This is A4 size, the width of the height of the A4 picture. Yeah, and if you zoom in, of course, you can see already there is a lot of grain, a lot of noise, because it's a JPEG file. Yeah. All right. So if you want to change that, we just change the file type or the file name to PNG, and let's run it again. Okay, save again, and we should have the image here. Now we have a JPEG image and a PNG image. So the difference between those two is, of course, we have JPEG and PNG. So if I zoom in, you can see already the difference, the pixels here, and if I zoom in here, PNG, it's much more cleaner. Yeah, so the distribution of colors is more even, and the contrast is kept. And that's, I think, is very important for PNGs. That's why I usually like to work only with PNGs when I export them. I use only JPEGs in terms of adding, extracting information when I get them from somewhere else, for example. All right, so this is the case. Now, one problem here is, of course, as you can see already, if I run the code again and I save the image again, because it's always changing, of course, it's generative work, so I would like to get a new image, but it's not. I always save the image on top of the first image, and that's usually not good. So what we need to do is we need to add a timestamp. Yeah, there's actually, there are two things. One is perhaps save image, or the other one would be we save frame, where we save each individual frame count, and we then use this hash mark. So now I do it this way, and you can see already I have the image, and let's check in this case. Did I save it? Nope, not really. One more time. There we go. Here's the first image with 02. So that's the second frame. When I press, it saves on the second frame the image. Now we could also save the third, the fourth, the fifth, the sixth frame. And that usually works like that. So you just put it inside here, into the save frame, and I remove maybe the no loop. Oh, sorry, I can actually turn on the loop, and when we see this, it's going to run. And when I press one time, second time, third time, fourth time, fifth time, and at each individual sequence, each individual frame count, I save the image. So at 47, 78, 123, and so on. So we have here quite a lot of images, and that's actually already quite good because we can individually give them each different name. However, that's, for me personally, is not good. Usually would like to use timestamps, and there are various ways to do it. So for this, I would like to use a timestamp. So let's have a look. First of all, I just put it like maybe images, and then I say plus timestamp, and it should add the image with the hash symbol. All right, so timestamp. How to do a timestamp? Timestamp should be a string. String means there should be just words or characters, and we call it timestamp. And then we say the timestamp should compose of year. Then I say plus just a dot, period, and plus month, because I have, like usually my archive has a lot of images throughout the years. And then plus again the same, and then plus day, then again day plus underscore, because now I want to add also even the time, not only the day. And we say hour plus and then plus minutes, minute, and then plus again the same, and then plus seconds and second, and basically that's it. Yeah, okay. So this is basically our timestamp. We put everything here inside. The timestamp will have a year, month, day, hour, minute, and second. And then it also attaches in the end the hash mark and also the file name, PNG. All right, let's run it and let's check it out. Okay, it's running, and I press the key. Okay, it saved the file. Let's have a look. And we can see already it's in the image sizes, and here's already the file name. The year, the date, the year, the month, the day, the hour, minutes, seconds, and then also the hash mark. So if you want to add the hash mark, we want to add into the file name the frames, the frame count, we need to use save frame, of course. And then the code will add into the hash, as the hash mark, the frame count. Okay, let's press the button S, and let's check it out. Here, there it is. I saved this image at 65 frames. Okay, so last thing I want to talk about is, of course, the size of the images. So we know already this is 842 pixels by 842, so that's an A4 size image, by 29 by 29.7 centimeter by 29.7 centimeter at 72 ppi. If I want to export this image as A4 and 300 ppi, I need actually a size of 2448 pixels by 3008. Yeah, so I would need to put this inside there. And let's check it. 48 by 3508, and remove this one. So now we have an A4 size at 300 ppi. So here we have 72 actually. And here we have A4 at 300 ppi. Okay, let's run the code. Oh, and there is already a problem. You can see already the image doesn't fit into the screen. That's one case. So the second case, even we save this image here in this case, second problem is, for example, that we encounter is that when we save the image, we have PNG files. They're great, and we know already PNG files have transparency. So if I put it into Photoshop and I make the background different color, you can see already that this file has no transparency. So how do we export transparent images and large images for print that we can also see on the screen? And that's a question for the next video, how to export raster images transparent and very large. So I'll see you in the next video. Thanks for watching.